to the cloud. I think there are some questions in the chat. Let me see. No questions. Okay. All right. I think yesterday we did section 5.
Professor, is Jenny, I'm here.
Right, and we did the. Sorry, say again.
I'm sorry, is Jenny, I'm here. I don't know the attendance already.
Oh yeah. Thank you. I got you. Thank you. All right. So yeah, I was saying we did the section 5, and we did section 2. So there's sections 3, 4 left, right? All right. So let's start with the section. I mean, of course, unless there's a specific request, but I'm gonna just start with the section 3, and then we can move to the section 4. So section 3. Well, actually, there are 2 parts in the section 3. There's the section 3.1 and 3.2. So for 3.1, we need to find like the mean, the mean, the median, the mode, right, of the data from Professor Hill's class, right? So we have like, well, 30 numbers, right? And it's in the data from Professor Hill's class. So of course, like in the test, guys, I mean, 30 numbers, that's a lot. So in the test, we're probably gonna have like 5 or 6 numbers. Okay. So well, anyway, so in the review sheet, we have like 30 numbers, right? So if you start with the mean, which is denoted by the way X bar. I guess probably I need to mute someone. All right, let me see. All right. Okay. All right. So X bar. So the mean is just a remind you the formula, right? So it's just the sum, all the sum of all data values over the size of the sample. So in our case, so we have like 30 numbers, 30 data values. You have like 15 plus 23 plus 17 plus etc. So we have 30 numbers, right, guys? Plus, and the last number, I think it's 9, right? Over size of the sample, we have 30 numbers, so we divide by 30, right? So then the mean. So now, if you do the top, right, 15 plus 23 plus 17, etc. I think the answer, if I'm not mistaken, the answer would be in the top 391, right? And so it's divided by 30. Okay. So then the mean, of course, you need to divide. So 31 by 30, which is actually equal to, I think, 13.03. Okay. So that's the mean, right? Next, I'm gonna see the chat. Of course, guys, if you have any question, please you can try me anytime.
391 or 392?
391 or 392? Let me see my notes. Well, I have my note 391, but I mean, it's possible that I did a mistake or something. But yeah, I think it's 391 from my notes. But again, I can make mistakes too, right? All right. So, but anyway, the idea, of course, as I said, so if for some reason, you made like some small mistake, like with this the sum here, with the calculator, but I mean, you have the right formula, right? You have the sum of your all data values divided by the right size of the sample, which is 30. You can get your 4 credits just for that. Okay. Even if your final answer is not exactly correct, right? I mean, so yeah. Next, we have the median. So for the median, guys, there are 2 steps. So first step, you need to order. You need to order your data values, or your numbers from from the smallest one, from the smallest to the largest one. Okay, so the smallest data value here, for example, would be 3. So we have like 3. We have actually we have 2 3s, right? Then there's 4, right? And then there's 5. There's only 1 5, if I'm not mistaken. Then there is 2 6s, right? 6, and then another 6, and then 7. There's only 1 7, I think. 1 7, 8 3 8s, right? 1 2 3. 9. We have like 2 9s, right? 2 9s. 10 2 10. Thank you.
3 11s.
3 11s. Thank you. And 1 12.
1 13.
13. Thank you.
2 15.
2 15s, right? 2 15s. And then 1 16. 1 17. And then let me see. Yes, 220.
123.
123. Thank you.
5.
125, and then
127. 128.
yes, 28, and then 30. 32. Right. So I think we have 30 numbers here. You can double check, guys. I mean, but you got the idea, right? So you have to order your numbers from the smallest to the largest, right? And then, so that's the first step. As I said, that's step 1. Now, step 2, right? So we need to find the center, or the position of the middle position, right? So the middle position. Okay, and how do we find the middle position? Well, here, like, you have like 30 numbers, right? So you have like you need to find the middle of your 30 numbers, right? But I mean, you can just take the size of the sample. We have 30 numbers. Okay, so that's size of the sample. Write it down here. So just take the size of the sample, which is 30 in our example, plus 1, always plus 1, and then divide by 2. So like here we have 30 numbers plus 1 over 2. So that's like 31 over 2. So the answer would be 15.5. Okay. Now, because of the 0.5, because of the 0.5, then the middle position would be between the 15th number and the 16th number, or 15th data value and the 16th data value. So the middle here, the middle position is between, because of the 0.5, it's between the 15th data value and 16th data value. All right. So then, now in step 3, we can compute we can find our median. So then median. So now you need to take the average of the 15th data value and the 16th data value. So we need to count, right? So like this 3, this is like my first number. The second 3, that's like my second number. Right? Second, this is the third. Fourth, so this is fourth, right? Fifth, sixth, seventh, eighth, 9th, 10th, 11th. So this is 12th, 13th. This is 14th, and this is this 11th. This is in the 15th position, right? This is my 15th position, and then the next 11, that will be the data value in the 16th position. So what we need to do now is we need to take the average of the two numbers in the 15th and the 16th positions, right? So that would be 11. That's the number in my 15th position, plus 11, which is actually in the 16th position, right? And then take the average. So we need to divide by 2, always by 2. So of course that will be 22 over 2. So then the answer is 11. Okay. So the middle position, guys, is actually between the two numbers. That's the middle position in this case. It's not the 15th position. It's not the 16th position. The middle is actually between the 15th and the 16th. Right? Any question about the median?
Professor,
see the chat.
why is,
Yes. Yeah.
why did you
Yes.
put 2 here in 11 plus 11?
Why did I divide by 2?
Yes.
Because you need to take the average of the two numbers, because we have two numbers, so you need to take the average. Like that will be the number between the two numbers. Right, the average is like the number between the two numbers, right? I have 11 and 11, so the number between 11 and 11, of course, would be 11.
It gets confusing because when we see 15, a lot of people may think that's the answer, but 15 is
No.
the place where you have to go.
Yes.
And that's where he got the 211, because it says
yes
15.5. So that's between the 15 and 16.
Yeah, so the 15th and the 16th, that's the position. That's not the answer. That's not your median. That's the position of, that's the position of your the center, or the middle of your data values. Yeah, that's not the answer. Yeah, absolutely. All right, guys. So that's for the median. Now for the mode. So I'm gonna just remind you what's the mode. So for the mode, that's the data value. So for the mode, so the mode is the data value that occurred the most frequently. So as you can see here, actually we got 3 11s, right? 11 occurred 3 times, 1, 2, 3, and also 8, right? 8 occurred 3 times, so 1, 2, 3 times, right? So actually our mode is 8 and 11.
I was going to ask you that. Can it be more than one mode?
Yeah.
Okay.
So it's 8 and 11, all right? So so the answer here, so mode would be actually is 8 and 11. Any question, guys? I'm gonna.
So if you see a number like
chat.
more than like 3 or 4 times, you know that's going to be one of your modes.
Well, the most frequently. So yeah, so you count, right? So because here, 8 and 11
More
they
than
occurred.
the others.
Yeah, occurred more than the others.
More than the others.
They occurred more than the others, right? They occurred 3 times. All the other numbers, they occurred, you know, less than 3. It's like either, I don't know, 1 time or 2 times, right? So, right? Does it make sense to you?
Yeah.
Why it's 8 and 11? Okay, that's the okay. All right. Oops, what happened here? Okay. All right. So now let's move to the B. In the B, we need to compute the weighted average. All right. So that's probably I'm gonna try it. So to answer your question, Kayla. So this is B. So in B, so we have this bio. So this is a bio 340. So we have the weights are assigned to assignments as follows. So we have a research. So there is a research project, which is actually worth 25%. So when I say worth 25%, it means the weight. So the weight of the project or research project is actually 25%. That's the weight of the project. Now we have 3 exams. Each exam is worth 15%. This is a 15%. 15%. And again, so the 15%, that will be the weight of the exams, of each exam. The weight of each exam, right? Weight. Right, and then there is a final, of course, a final exam that's 30%. Final, it's worth 30%, and that will be, so that's the weight of the final here. All right, so so we have a student, his name is Gary. So Gary got 75 on a scale of 100 point, of course. So he got 75% on the project, so 75% project, 85 first exam, 95 on the second, 290 B, and then 88 on the final. Okay, so that's Gary's scores. All right, so we need to compute the weight, Gary's final grade, or his weighted average. So Gary's final grade. So Gary's final grade. So that would be a weighted average. Weighted average. Okay, so that'll be equal to, so what we do, guys, so we'll multiply each score by the corresponding weight. So for example, Gary got 75% of the project, and the project is worth 25%. So that will be the weight of the project. So we need to multiply, so that'll be 75% by the 25. Okay, and then it's a plus, right? It's not a multiplication. I know some of you, sometimes, it's easy actually to get confused here. But yeah, so you have multiplication, but then it's a plus. Then you move to the first exam. First exam, Gary got 85% times the corresponding weight. So each exam is worth 15%, so times 15 plus, so etc. So next exam is 95 times 15. Third exam, he got 90% times 15 plus, and then the final he got 88% times the weight of the final, which is 30%.
Okay, so I did my stuff like that.
Mm-hmm. But then you divide. So we are supposed to divide this whole thing here by the sum of the weights. So here in the denominator, that's the sum of the weights, not the scores, but the weights. So the weight of the project is 25%. It's worth 25% plus first exam, that's 15 plus another 15, another 15. And finally, there is a final, which is 30%, right? So now, guys, all right, so you can convert the percentage into decimal, right? So like 75%, that's 75 over 100, right? So 75% is just like 0.75 times 25%, that's 25 over 100. So that's 0.25, right? Plus, etc. So 85%, so this is a plus, of course. The 85%, just that's 0.85, right? Divide by 100, that's 0.85 times the 15, etc. So 0.85 times 0.15. I don't know if you're gonna have time to finish everything here, but 0.15 plus 88, which is 0.88 times 0.30. All right, so this thing here, this whole thing here divided by 0.25 plus 0.15 plus 0.15 plus 0.15 plus 0.30. All right, so what we do, guys, so in the top, first PEMDAS, because of the PEMDAS rule, we need to multiply first, right? Do all the multiplication, right? So first we have 0.75, right, times 0.25, so that will be equal to 0.18, this is 0.1875, right? So I just multiply these two numbers right here, okay? Plus, and then you continue, right, the multiplication, because we have, so next we have this 0.85 times 0.15, so that'll be equal to, of course, 0.12, oops, 1275, 0.1275, right? So there's another plus, and we do again, 95 times 0.15, so that'll be equal to 0.14. So this is, so you do this multiplication here, then this one here, that's 0.14 plus 0.1425 actually. I mean, it's up to you. You can round up your numbers here. It's up to you, okay? And then, of course, and then there's a 0. So there's this 0.90 or 0.9 times 0.15, which is actually equal to 0.135. Oops, 0.135 plus, and then the final, for the final, we have this 0.88, right, times 0.3, which is actually equal to 0.264. So plus.
Right. Oh, I'm on.
So yeah, be careful. Just be careful. You need to be careful when you use your calculator, right? Especially decimals, because all right. So that's the top. The denominator, it's just a sum. So you can just go ahead with the sum, right? So the 0.25 plus 0, the 15, etc. So that would be actually equal to 1.00, which is 1, right? So the denominator, it's just 1.00, which is 1. Okay. Now you add the top, you have your
I got something different. I got 0.8565.
where in the denominator?
No, when I added up
No.
all the when I did all the sums, I don't even know how I got that wrong, because I have everything you have.
Where in the top or in the bottom? In the
On the
denominator?
top. Oh, I'm on the top. I got everything on the top, and then.
So the sum here, I think it should be 0. Let me see, 8.84. I think it's 85. Thank you.
Yeah, that's what I got. 0.008565.
Yeah. So yeah, it's 0.8565. That's the right answer over 1. So that's a 0.8565.
Oh, I did over 100.
No, that's not over 100. That's over 1. That's
okay.
The bottom. It's 1.00, which is 1. It's not 100. It's 1.00. Just be careful, right? I understand why you're confused, but this is, there's difference between 100 and 1.00. 1.00, you can just ignore, the zeros after the decimal point. So it's just, it's just 1.
Oh, because the bottom, because when we were adding the bottom, the 0.25, the 0.5, 0.5, that's how you got the 1. Okay.
Yeah, that's how I got the 1, of course.
Adding 0.25, 0.5.
Any other question, guys? Let me check the chat. I see there are 2 questions. There's something in the chat. What time the exam? It's from 12 to 2 p.m. So I will post the exam at 12 p.m. on CUNY Blackboard tomorrow. Yeah, so tomorrow at 12 p.m. on CUNY Blackboard. All right, guys, let me move now.
Just one quick question, Professor. So
yes,
when we get to that point, when we do like how we got the multiplication on the top, and then you have the bottom, We
Mhm.
always have to add that up. It's not always gonna obviously equal 1, but whatever that
No,
equals,
yeah,
that's the bottom.
Yeah.
It's not always gonna be the top number divided
no,
by 100.
no.
Okay. All
Yeah, it
right.
depends on the problem, yes. All right, so
It
let's
depends
move
on
to
the weighted average,
the weights.
depends on
Depends
the
on
weight.
the weights, yeah, depends on the weights, yeah. And of course, the weights depends on the problem.
Yep.
Mhm.
Okay.
All right, guys, so let's now move to the section 3.2. So this is section 3.2. All right, so section for 3.2, that's the measures of spread, or measures of variation, right? So we have the range, we have the standard deviation, of course, etc. So let's start with the range. So A, you need to find the range. So A, it says you need to find the range of the data from Professor Hill's class, right? So the range, I'm gonna just remind you the formula for the range. So it's just it's very simple. It's just the largest number, largest minus the small difference between largest and the smallest data values. All right, so like here in this case, the largest data value is 32 minus the smallest data value, which is so the answer is just 29. 29. That's the range. Okay. All right, now next is standard deviation, right? So the standard deviation, it's well, it's more complicated than the range, of course. So we need to follow a couple of steps here for the standard deviation, right? So now I'm gonna compute the standard deviation S. All right, so first step. So to find the standard deviation, first step, you need to compute the sum of the x squares. So what's that? Well, sum of the x squared. So we take the square of the first number. Well, here it's like 30 numbers, right? That's a lot. But of course, in the test, you would have like less numbers, right? You would have, as I said, 5 or 6 numbers at most. So, but first number is 15. So you need to take 15 square plus second number is 23, right? So like that would be like 23 square. Next number would be 17. So that's plus 17 square, right? Etc. Right? So we have 30 numbers plus. So last number would be it's 9, right? So that's 9 square. And be careful, guys. So the square means it's 15 multiplied by itself. It's not 15 by 2, it's 15 by 15. Right? This is like 15 by 15, 23 times 23, etc. Right? So for example, 15 times 15, that's 225, right? Plus, etc. Okay. So that will be your sum of the x squared. That's what we mean by the sum of the x squared. Now, the step 2. You need the sum of the x's. So step 2, we need to compute sum of the x's. Okay. So that's sum of the x's. It just you take first number 15 plus the second number plus the third number, right? Plus etc. I think we did this. So we compute the sum of all data values. And that would be 390, 391 or 392. Well, anyway, so let's say it's 391. That's what I have in my notes. But anyway, so again, it's just the sum of the numbers, right? It's 15 plus 23 plus 17, etc. Right? That's the second step. Now, you need to take this as the next step. So let's say this is step 3, right? So step 3. So we need to take the square of the answer of the step 2. So we take the square of this square of the sum of the x's. Okay. So it's just it's 391 squared.
For me, it was 15,360 64.
You're talking about this is step 3, this one,
Wait, is
or
that
first step?
no, the first step it was 6,524.
Yes. Oh, yeah. Sorry, I forgot. Yeah, step 1. Yeah. You're right. You got it. Yeah, that's correct. Now for this here, I need to take the square of this 391, right? So it's just 391 times 391. If my 391 is correct, of course, that would be 152,881. Okay, so again, it's just like 391 times 391, right? All right, guys, now in the step 4, we need to divide this answer by the size of the sample. So step 4, divide, so the answer from step 3, from step 3 by the size of the sample, which is n, right? The size of the sample, it's denoted by n. So we have 30 numbers, so we need to divide this 152,881 by 30, which is actually 5,096. So 152,881 divided by 30, that's 5,096.03. Okay, now we can compute our step and last step. So now I can compute my standard, my standard deviation. So step 5. All right. So in step 5, we have actually the variance. So variance is denoted by S squared. So in the variance, so we have you have the sum of x squared. So this is from the first step. So this is step 1. That's the answer from step 1 minus the answer from step 4. So I'm gonna just write here sum of the x squared over n. So this is a step from step 4. From the step 4, the answer from step 4. Sorry. And then you need to divide by n minus 1. Again, n, that's the size of the sample. So this 29, which is 29. Thank you, Yanni. Yanni. So this is S squared. So from the step 1, we said, I think the answer is, where is step 1? It's 6,524. 6,524 minus from step 4. We said, where's the answer from step 4? Yeah, right here. It's 5,096 and divide by 30 minus 1. So it's 29. Okay. So yeah, so the answer is, let me see. So it's 6,524 minus the 5,096, if I'm not mistaken, of course. So this is 14, 20, 28, I think. I mean, if I'm correct, of course. Over 29, we divide by 29. So then the answer is 49 point something. Okay, I think point 24. Okay. Again, guys, if all your steps are correct, you are using the right formulas, right? But then for some reason, I don't know, you got like the wrong answer because I don't know, you had the trouble with your calculator or something. You're gonna probably get full credits. Okay, of course it depends on the problem. I need to check, very carefully your steps, etc. But yeah, so if you're using the right formulas, the right steps, you're gonna probably get your full credits, even if your final answer is not totally correct. Okay, all right. So that's the variance. So now my standard deviation would be the square root. So that's like the last step, right? So step 6. So then the standard deviation S So standard deviation S, it's square root of S squared. So that's the square root of the answer from step 5, which is step 5. So that's the square root of 49.24. And the answer here, I think, is it's equal to 7 point, I think, 0.1. So that'll be the standard deviation, S. So this is my S, standard deviation S. All right, guys. Okay, let me see the chat. Okay, no questions in the chat. All right. So yeah, so in the test, guys, just try to follow the steps. Oops. So just try to follow those steps, okay? If you have trouble with your calculator, of course, just take your time. Yeah, just make sure you have the right formulas. All right, so that's for how much time left? Okay, we still have like 40 minutes. All right, so that's for the range of variance as standard deviation, right? Now in B, so in B, it's about this Chebyshev's. So Chebyshev's interval, right? So let me just remind you the formulas here for the Chebyshev's interval. So if you see, like in the problem, if it says like at least 75%, then the Chebyshev's, come on. So if you see at least 75%, then the Chebyshev interval would be x bar minus 2s, x bar plus 2s. So the x bar, again, that's the mean, and s, that's the standard deviation, right? If you see like at least 88.9%, so that would be x bar minus 3s, x bar plus 3s. If you see 93%, so then the interval, your answer would be x bar minus 4s, x bar plus 4s. So like here in this problem, so let's come back to the problem in the review sheet. So in the problem, it says, so we have this random sample of receipts of individuals eating in the Applebee's restaurant. So we had a sample mean of x bar. So we have x bar equal to $10.38, and s, the standard deviation, it's equal to $2.17, right? It says we need to compute the coefficient of variation, okay, denoted by C dot V dot, okay? So CV dot stands for coefficient of variation. So just to remind you the formula of the coefficient of variation, that's S over divided by X bar times 100. And then there is percent. Okay, so that's the formula. So like in this example, the S is, we said it's 217 over X bar, which is 10.38. So all we have to do here, guys, is to divide 217 by 10.38 and then multiply by 100. So so our coefficient of variation in this case, so it's 2.17 divided by 10.38. So that will be equal to 0.20, right, times 100, and then percent. So then the coefficient of variation is 0.20 times 100. That's 20%.
I did mine wrong. I did 10.38 minus 2.
No, there's no subtraction here. So just divide the S by the X bar. Okay. No, probably you're talking about the interval. Here we're not talking about the Chebyshev interval. So here, this is the formula for the coefficient of variation. So that's different from, that's not the Chebyshev's interval.
Oh, okay.
So this is coefficient of variation, right? So this is, and though this would be the formula for the coefficient of variation. Now the interval. So it says after that, so it says use the Chebyshev theorem to find the smallest interval centered on the mean in which we can expect at least 75% of mean receipts to fall. So here you see there's it says we can expect at least 75%. So now so this is the second part of the question, right? So we need to find 75% Chebyshev's interval. So yes, so then the answer, as you said, Chebyshev's interval. So then the answer, so because it's a 75%, as I said, guys, then the interval would be the X bar minus 2S, X bar plus 2S, right? It would be this one. So it's X bar minus 2S, X bar plus 2S. So then X bar, it's of course, $10 or $10.78 minus 2 times the S, 2 times the $2.17. X bar plus 2 times $2.17. All right, so here, just be careful because PEMDAS rule, you need to multiply first, do the multiplication first. So it's $10.78 minus, so 2 times, right? We do the multiplication first. So multiply by 2 first, the $2.17, so that's $4.34. So here it's $10.78 plus $4.34. So then the answer, so now we subtract. So that's $6.04. And here it's $14. That's not a comma, it's supposed to be a decimal point, 0.72 cents. Okay, and that's the final answer. So I guess probably, Kayla, you mean this, right? For the 2 minus 2S plus 2S, I guess probably you mean this, right? So this is what I call what we call the Chebyshev's interval, right? So this is the Chebyshev interval, but in the first part of the question, it was the coefficient of variation, right? This one here, that's the coefficient of variation. Do you hear me, guys?
Yes.
I think
Yes.
there was a, okay, because I think there's an issue with the Zoom. All right, okay, so I'm gonna share again the board. Please let me know if you see the whiteboard. Okay. Do you see the whiteboard?
Yes.
Yes.
Yeah, okay, perfect, thank God. Okay. All right, thank you. I'm gonna just check if it's still recording, because sometimes it stops for no reason. Is it still recording? Let me see. Yeah, I think it's recording. Okay, thank you. All right, good. Yeah, so there's X. So the X represents the length of a northern pike in inches, and the y, the variable y, that will be the weight in pounds. The weight. All right. So you have your your table with the data pairs, right? I'm just it's just a 4 numbers, so I guess I have time to write down the numbers here. So 1, 2, 3, 4, 5. Right, so we have like 20, X is 20, then Y is 2, 24, 4, 20, 36, then it's Y is 12, 41, this is 15, and then 46, that'll be 20 here. All right, so in A, it says you need to create, or you need to graph your scatter diagram. So the scatter diagram, we're gonna have 2 axes. There is the x-axis, the horizontal axis, that'll be your x-axis, right? And then the y-axis, the vertical axis, that'll be your y-axis. All right, so then here's 0. So now the values of x, as you can see here, this is the values of x. So it goes from 20 to 46. So I'm gonna just plot the values of x. So here's 20, there's 24, there's 36, there's 41 here, there's 46. And then there's the values of y. Okay, so we're gonna plot the values of y. So it goes from 2 to 20. So like 2, there's 4, it's like 12, it's like 15, and there's like 20. Okay. All right, so when x is 20, y is 2, right? When x is 24, y is 4. So this is 24, of course, so we need to go up to 4 here. When x is 36, then y is 12. So it's somewhere here. When x is 41, your y is 15. And when your x is 46, then your y is 20. Okay? So this is your scatter diagram. By the way, guys, I mean, like in the test, of course, the diagram, it doesn't have to be perfect, right? The units, they don't have to be like exactly the perfect, okay? They don't have to be perfect. So you can just, try to use your own units, okay? All right, so, and then it says, using only the scatter diagram, would you estimate the correlation coefficient to be positive, close to 0, or negative? Explain your answer. So here, as you can see, your data resembles a line, right? So this is like this line here. Okay. Most of the points, they actually lie on this blue line. So this line, of course, goes up. It's increasing. So because the lines going up, then the correlation is positive, right? So the data here, in this case, resembles a line, resembles a line, and the line is going up, right? The line is going up. So then, because it's going up, then the correlation, of course, is positive. is positive. Okay. Of course, if your line goes down, then your correlation is negative, right? All right. So then, of course, yeah. So then I guess we can move to the B. In B, it says, well, you need to compute X bar, Y bar. So X bar, Y bar, that would be the mean of X. So in B, let me see if there's any question in the chat. Okay.
I
Questions
wanted
in the
to
chat.
ask
Perfect. Yeah, please.
when it has the, it looks like the X bar, it looks like finding the mean. Do we
Yes.
have to also find the mean for Y?
Yes, because here it says X bar and Y bar. So whenever you see like a bar, that will be the mean. Yeah.
Okay.
That's the notation for the mean. Yes. So yes, that's a good point. So X bar, that's the mean of X, the values of X, mean of the values of X. So in other words, you need to take the sum of all X's, sum of all X's over the number of X's. So here we have, of course, the 5 values, right? So your X bar would be like 20 plus 24 plus 36 plus 41 plus 46, right, over 5. Which is, by the way, let me see. So this is 80, 220, 121, 127, yes. So what I'm saying. So that's 80, 121, 127, and 167, right? Over 5. So then X bar, that's 167 over 5, which is actually equal to, let me see my notes. So it's 33.4. Okay. The same for the Y bar. So it's asking for the Y bar. So that's the mean of the values of Y. Y bar, that's the mean of the values of Y. So we need to take the sum of all the Y's over 5. So that would be
53
yes.
Over 5, and that's 10.6. I have a question for that.
Yes. Yeah.
We have to do the same as when we're doing the first activity. I can't remember the name, that we add 1 so it can be a whole number. Oh, I'm sorry, not add 1. Move it up to the next integer so it can be
No.
You're
talking about no. You're probably talking about the width. No.
Right. We don't have to do that here.
No. You don't. No. The mean is just the answer you get. Yeah.
Whatever it is.
So
Okay.
yeah, wherever it is. Yeah. 2 plus 4 plus
10.6.
Mm-hmm. So over 5. Yeah, it's 10.6. So the top here. So it's 18, 38, 43, 53 by 5. So as you said, that's 10.6. All right, guys. Now you need to compute the R, right? This is where things get a little bit complicated, right? So in C, just take your time with the R. I mean, I know it's a lot, but the formula is a mess. But yeah, so it says you need to compute the sum of the x's, y's, x squared, etc. So I'm gonna just write down here like sum of the x's. It's just 20 plus. You take just the sum of the values of x plus 36, 41 plus 46. So that's 167. And then you need the sum of the y's. So just take the sum of the y's, which is 2 plus 4 plus 12 plus 15 plus 20, which is 53. All right. And then it says take the sum of the x squares, which is, so you need to take the square of each value of x. So like first value of x is 20. So that's 20 square plus 24 square plus 36 square plus 41 square plus 46 square, right? And again, 20 squared, that's not 20 times 2, that's 20 times 20. So that's like 20 times 20, that's 400, right? Etc. And the answer, okay, let me see my notes. Does anyone have the answer for that? For the sum of the x square?
69.
Yes, it's you're saying it's a 669, right?
6,000.
Sorry, 6,000. Sorry, 6,000. Yeah, 6,069. I think, yeah. All right, thank you, Yanin. And then we
So
do.
Professor,
Yes.
the top is the adding, it's adding the x's, right? And then it's the same thing for y, right?
Yeah, yeah.
And then
This is-
and then it's sum of the x2. And so that's the squared. So I'm
The square.
squaring
Yeah.
step 1, I'm squaring it, right?
You don't know, you don't square the answer of the
The
first step
numbers,
one.
the numbers.
The numbers, yes, you're
Yeah, I'm
squaring the
gonna
numbers.
square the numbers. So
Yeah, yeah.
add,
Mhm.
add, square. So it's add, square.
Yep.
Okay, so the first 3 steps, add,
Mhm.
square.
And you do the same for the y. So y square. So take the first y squared plus next y squared.
Okay.
Just guess.
Fucking brain is
So-
in a million places. Oh, I'm sorry.
Sorry. All right. So 12 square plus 15 square plus 20 square, right? So that's like, so again, this is like 2 square, that's 4 plus 16. So plus 12 square, that's 144. 15 square, that's 225, and 20 square, that's actually 400. So sum of the y square is actually, say again, Yanin, sorry.
789.
789. Thank you. All right, now we're almost done. Almost done. So come on. Oops. Sorry about that, guys. I don't know. Sometimes it's just the board froze for freezes for some reason. Anyway, so then we have the sum of the x times y. So we need to multiply each x with the corresponding y. So first x is 20. So we need to multiply by its corresponding y, which is 2. Next x is 24 by 4 plus, right? This is a plus here. Next x is 36 by 12. Next x is 41 by 15. And then next x is 46 by 20. Right? So you do the multiplication first. So 20 times 2, you know, that's 40. 24 times 4, that's 96. You know, 36 times 12. Let me see my notes. So that's 432. Thank you. And then 41 times 15, that's equal to 615. Thank you. And 46 times 20, that's 920. And the answer, what will be the answer, Yanin? If you have it, it's 21.
Yeah, 03.
03, yes, 2103. Yeah, exactly. That's what I have in my notes too. Thank you. All right, guys. So that's the C, right? Now we need to compute in D, we need to compute R. So I'm gonna write down the formula for R, and all you have to do now, of course, is to plug the numbers in the formula. So let me just first remind you the formula for R. So it's N times the sum of the XYs minus sum of the x's times the sum of the y's over, and then there's like these two square roots. Of course, here is multiplication. So this is a multiplication right here. So
Professor,
we have, yes,
we have to do the number of variables times the computation of x and y?
yes, that's what I'm gonna do now. Yeah.
Oh, okay, that's, oh, yeah, okay.
Yeah, I'm gonna just write down the formula. Yeah. You're
Yeah,
right.
go ahead.
You're right. Yeah. So, and then n times the sum of the x square minus square of the sum of the x's. I'm gonna just plug the numbers here. So same thing for y's. It's n times the sum of the y square minus the square of the sum of the y's. All right. So let me explain now how to plug the numbers. All right. So your R is equal. So first, there's this n, right? This n is just the number of data pairs, right? We have 5 here, 5 data pairs. So n is 5 here. So n is 5 because we have 5 data pairs, right? It's 5 times next sum of the x times y. So that's from the, come on, first the first step here. So sum of the xy, it's right here, and we said it's 2103. So it's 5 times 2103 minus, and then we have the sum of the x's. All right, so sum of the x's is just this first number right here. Sum of the x's, sum of the values of x, it's 167. So it's, oops. So it's minus 167 times, and then there is a sum of the y's, just the sum of the values of y, right? Sum of the values of y, we said it's 53, right? Sum of the values of y. So here it's 53. Right, over, then there's this square root, there's this n again, which is 5, times the sum of the x squared. Now we take this sum of the x squared. You see here, your x squared, the 20 squared plus 24 squared plus etc. So that's 6,069. So here, come on. So it's 6,069 minus, so here, just be careful, guys. You see there's a square outside the parentheses, right? So inside the parentheses, there is this sum of the x's, sum of the values of x. And we know the sum of the values of x is actually the 167. So inside the parentheses, we have 167. So it's 167, and then there is a square. Times, and now the same thing with the y's. So it's 5 times the sum of the y square, right? The square of the values of y. So that's this is a 789. So it's a 789 right here minus, and then you see this parenthesis again. Inside the parentheses, you see that there's a sum of the y. The square is outside. So first, you need the sum of the y's, the values of y, which is 53. So we have 53 inside the parentheses, 53, and then there is a square outside. Okay. So just be careful, guys, when you plug the numbers. This is, I guess, this is where the confusing step, right? So just be careful. Now, we can do the top and the bottom at the same time. So in the top, we have, as you can see, we have multiplication, right? And there is a subtraction. Of course, PEMDAS rule, you need to do this multiplication first. So for example, here, you need to multiply the 5 by the 2100 03, right? So that's, for example, would be equal to 10,515 minus, right? And here on this side, it's again, it's another multiplication, right? We do the multiplications. So 167 by 50 times.
8,000.
Yes, it's
8,851.
851. Yes, thank you. Absolutely. Over. Now, the square roots, again, you need to go step by step. Do the multiplication first, then the subtraction, and then the last step is the square root. So multiplication first. So there is this 5, this 5 times 6,069, which is actually equal to 30,000. So this is 30,000, 345 minus, and then there is this 167 square. So this is like 167, times 167. Okay, which is actually equal to 27. Yeah, 27,889. Now I'm gonna do here the 5 times difference, the 5 times 789, which is actually equal to 3,000. This is the 3,945 minus, and then there's this 53 square. By the way, guys, if you get a negative number under the square root, then it means you made a mistake. You are not supposed to have negative numbers under the square root, okay? So this 53 square, this is 53 times 53, which is 2,809. All right. So now we can do the, come on. So now we can do the subtractions. There is a subtraction in the top. The 10,515 minus the 851, which is actually equal to 1,664. Right? This is the top here. All right. In the denominator, there's this square root, and there's this another square root. We do the subtractions under the square root, right? And as I said, if you get a negative number under the square root, then there's something wrong. So this is 30,345 minus 27,889, right? So then the answer is 2,456. So this is a positive number, right? The other one, it's there's this 3,945, right? Minus 2,809. So that'll be equal to actually 1,036. Now, be careful when you apply the square root. So there's a 1,664 in the top. Take the square root of, you need to take the square root of 2,456. So the answer would be 49.55 times, and then you need to take the square root of 1136, right? Just make sure, guys, you know how to get the square root with your calculator, okay? You can try this at home. Try to compute the square root of 2456. So it should be 49.55. Square root of 1136, that's actually 33.7. All right, now next operation is the multiplication here, in the bottom here. Okay, I did the square roots. Now I multiply the numbers in the denominator, right? The 33.7 by 49.55, which is actually equal to 1,670.06, I think. Right. So now the final thing is to divide 1,664 by the 1,670, which is almost 1, right? This is almost 1. So this is actually equal to 0. So this is 0.916. Yeah, so it's 0.99. It's almost 1. Okay. And so because it's very, very close to 1, so it says in E, so this is my R. So again, the R, guys, the final answer in R, this must be a number between -1 and +1. So this must be between -1 and +1. So if you don't get something which is between -1 and +1, then there's something wrong. All right, so then E, and E it says, is the correlation strong, moderate, or low? Explain. So my R, it's 0.99, and that's very, very close to 1. Very, very close to 1. It's almost 1, right? To 1. So when your R is very close to 1 or -1, then the correlation is, of course, is very strong. This is a very strong linear correlation, right? So then the correlation is very strong. It's strong. Okay. Because again, because R is close to 1. Because R close to 1. So if it's close to 1 or -1, then the correlation is strong. If it's close to 0, then the correlation is very low. Okay. And if it's close to half, 0.5, or close to -0.5, then the correlation is moderate, right? All right, guys, let me see. Is there any question about this R? So you get your R, and then you see if your R is close to 1 or close to 0 or close to 0.5. Close to 1 or -1, then it's the correlation is strong. Close to 0, then the correlation is low or weak, or right. And if it's close to half, of course, 0.5 or -0.5, then the correlation is moderate. Any question? Let me see. There are 3 questions, I think, in the chat. Let me check the chat. Sorry, guys. Oh, Yanin,
have
you
a
got the
question.
answers. All right. Yes, please.
For the test, how will the
Yes,
layout
go
look
ahead.
like? When we do the test, like, would it be on like Microsoft Word or like?
No. Just no. So the test is gonna be like a PDF file, of course, on Mini Blackboard, like for the homework. But then just just take picture. You can take pictures of your answer, right? And you can upload them on Blackboard. You don't
Okay.
don't bother yourself with Microsoft Word or anything.
All right. Thank you.
Sure. All right, guys. I guess we are done with we covered everything in the review sheet. So yes, I guess I'm gonna stop here unless there are any other questions. I'm probably gonna stop. Yes.
Can
Yeah,
I
please.
email it to you?
Oh,
My
okay.
picture of the set.
Okay, sure. All right, guys. I'm gonna probably stop sharing and stop recording.